This is yet again a difficult quiz for students, but mostly because they aren't careful about how they do this and they haven't tried the practice quiz before they've watched the video. So be sure you've actually tried the practice quiz because it's really easy when you're listening to me explain this. Think to yourself, oh, that makes sense, I can do that. But do you really know if you can do it or not? So you really need to try it first. The first two questions on the quiz will simply be questions using the moles equation. Moles is equal to G over GFM. And that you can always look up in Table T on the back of your reference tables. So let's look at question number 1. It says how many grams, so we're actually going to be looking for the G in our equation. How many grams, so we're actually going to be looking for the G in our moles equation, of carbon dioxide. This is one of those that doesn't use our naming system that you just have to memorize. Just like water, we never say whatever the chemical name should be of water. We always say water. Same is true for carbon dioxide. Are present in 12 moles of the gas. So they have given us our moles of substance, which is here. We're looking for the grams. We need to figure out the GFM before we can actually calculate this. So in order to do that, we're going to need our periodic table. Carbon is right here, and I need to zoom in more for myself. The mass of carbon is 12.01. Remember, we always round to 2 decimal places. And then oxygen, when we round that to 2 decimal places, becomes 16.00. So I'm going to tuck that away. We have 1 carbon at 12.01. So that's just going to be 12.01. And then oxygen, we have 2 at 16.00. So that's 32. We add those up, we get 44.01 grams per mole. That was just the work to get the GFM. We've been given moles, so we're going to plug that in. So we have 12 moles is equal to G, or if you prefer to make that an X, you can. That's what we're solving for. And the GFM we just calculated to be 44.01 grams per mole. Most of my students like to make this into a proportion, so over 1. And then what you really only need to do is multiply this times this. Because when you multiply G times 1, you're just going to get G. And your answer is 528.12 grams of carbon dioxide. And we have a different example, again, just using the moles equation. This time they want to know how many moles, so this time we're actually going to be solving for moles of potassium chloride are present in 87.50 grams. That is the G in the equation, and then we need to figure out the GFM so we can solve for moles. That's what we'll be solving for. Before we can do that, though, we need to figure out the formula of potassium chloride. Potassium, you may need to look in Table S, is K, and then chloride implies chlorine in a binary substance. Now we look up the oxidation numbers. Potassium is +1, chlorine is -1. So we're not going to be using any subscripts or anything like that in figuring out our GFM. We do, however, now need to figure out our GFM. So we have 1 potassium and 1 chlorine. So let's look up their masses. Potassium, when we round that, it becomes 39.10, and chlorine way over here is 35.45. And then we just add those up to get the GFM, and we get 74.55 grams per mole. Now we can plug into our moles equation. We're solving for moles this time. They gave us 87.50 for the given mass and 74.55 for our GFM. Now we just divide and we get 1.17 moles, and that was moles of the KCl. Those should be some of the easiest questions on the test for you. Just make sure that you know what you're looking for. Those aren't supposed to be terribly complicated. The only way it might make it more difficult for you is that I'm giving you the name of the compound and not the formula. So you still need to remember those things we learned at the beginning of this unit in naming and formulas. The next few questions are going to refer to the equation given to you at the top of the section. So these are going to be moles and equations questions, and there will be 3 of them, all based on the same reaction. So each of these questions are referring back to that reaction. Question number 3, how many grams of iron 3 oxide will be produced from 250 grams of iron? You could at most be asked to do 3 steps in any of these questions. The first one being that you have to go from grams to moles. The second part being moles of one substance to moles of another substance. And the last section of the question going from moles of that new substance to grams of that substance. In chemistry, it would be most likely that you would always do all 3 of those steps because you can't have a scale that measures moles or anything like that. It's really hard to measure moles, but gee, it's pretty easy to measure mass, as you've discovered in lab. So this question is asking for grams. So in the end, we have to get to this at the end of this. So we know we have to do step 3. We always have to do step 2. And then looking at the question, they gave us grams. So we do need to start here where we start with grams. So in this first and in the last actually section of it, all we're using is the moles formula that we used above. And we're going to plug in our given mass and the GFM in order to solve for moles. In this case, our given mass was 250 grams of iron. So they're actually referring to this in our reaction right here. And the GFM of iron is simply its mass from the periodic table right here. And when we round that, we would get 55.85. Okay, now I'm just going to do the math, dividing. And I get 4.47 moles. So that's now moles of iron. So over here in step 2, where we set up our proportion, I know that one side of my proportion needs to have the coefficient from iron. So that's going in the denominator on one side. And we're looking for iron oxide. So this is the iron oxide. I'll put that coefficient on the other side. So this is my iron side, and this is my iron 3 oxide side. Now I'm going to take, because the normal proportion is 4 to 2, but I don't have 4 moles, I have 4.47 moles of iron. So I'm going to take that number and put that there, and then put the X over here for what I'm looking for. Now you know that I like to keep it simple, and all I'm going to do is cross multiply one side. So I have my 4.47 times 2, then I'm going to divide it by 4, and my answer is 2.235, and that is moles. And And if you forget what you just solved for, look where your X is. Your X is here by the iron oxide. So that was moles of iron 3 oxide, which is great, but in our question they want grams of that. But that's the easy part. We're just using the moles equation again. This time we have the moles, the 2.235 moles. We want to know the grams, and now we need to figure out the GFM of the iron 2 oxide. And actually I'm going to label these things up here because then I don't have to keep looking it up. There's the GFM of the iron, and now we're going to figure out the iron oxide. So iron, we have 2 of them times the 55.85, and then we have 3 oxygen at 16.00. So we have 111.70, and we have 48 from the oxygen, and just add that up. And we get 159.70. So that's the GFM I'll use down here. And then to solve that, all I'm going to do is I'm going to assume this is over 1 and then multiply these two. I don't have to multiply the other two anyway, but even if I did, I'm multiplying by 1, which would just give me grams. So I'm really taking that GFM and multiplying by 2.235, and my answer is 356.9 grams. And that is what I would expect to yield in that reaction. Kind of a long question, but that's the hardest thing I could expect you to do. What I would do for each of these questions is go ahead and separate it out into 3 and then look at what your question is asking you. It is asking for grams. I am going to need step 3 in order to get to grams of anything. But in this question, they gave us moles. So we don't need to start with grams to moles because we already have moles, so we don't need that first step. We're going to start with step 2 and set up our proportion. The 2 compounds from our reaction they're asking about are iron and oxygen. So we're going to set up our proportion with iron on one side and oxygen on the other. We're going to put the coefficients from the equation, so I'm going to pull this down a second. Iron, the coefficient is 4, oxygen is 3. So 4 here, 3 here. And then in our question, we didn't have 3 moles of oxygen, we have 8. So that 8 is going to go up there, and we're going to look for moles of iron. Now when I solve this, I'm only going to half cross multiply, and I'm going to do 8 times 4 and then divide it by the 3, and I get 10.67 moles of iron. But our question isn't asking for moles, it's asking for grams, so we're just going to use our moles equation. Where we have 10.67 moles, we're looking for grams, and we already looked up the GFM of iron. It's 55.85. And now all I have to do is multiply these two. So my 10.67 times 55.85, and I get 595.9 grams, and that's grams of iron. So that's a little bit easier. Not the easiest. The easiest would be if I only asked for step 2. Next one, again, I'm going to separate it into 3. The question is asking for grams of oxygen, so I know I'm going to have to go through step 3 to go from moles to grams. We always have to do step 2 in a moles and equations question to go from moles of one substance to moles of another. Now let's look at what else they gave us. 500 grams of iron 3 oxide. So I'm starting with grams. So in order to do step 2, I have to do step 1, which is go from grams to moles. We're going to use our moles equation, which we see up here in this question. And we're going to use our GFM we calculated here, 159.7. So our moles is going to be 500, that's our given mass, divided by the 159.7 grams per mole. And this is going to give us our moles of iron oxide, which works out to be 3.13 moles. And I'm going to label that with the formula so I don't forget what I just figured out. Our next step, our moles to moles, we're dealing with oxygen and the iron 3 oxide. So on one side, doesn't matter which side, I'm going to have my oxygen. On the other side, I'm going to have my iron 3 oxide. And my coefficients I need to get from my question. My oxygen is 3, my iron 3 oxide is 2. But I don't have 2 moles of iron 3 oxide, I have 3.13. So I want to find out then how many moles of oxygen I would need. So now to solve this, I'm just going to do my half cross multiply. And then divide by 2. And when I do that, I get 4.695 moles. And what I just calculated was moles, where's my X? Right here by oxygen, of oxygen. Let me look back up at my question. I'm not looking for moles, I'm looking for grams, but we know how to use the moles equation to figure out grams. So I have my moles. I'm looking for grams. And the GFM of O2, oxygen is 16. I have 2 of them, so that would be 32. And I just multiply. And when I do, I get 150.24 grams of oxygen. And that is my answer. The back side of this quiz is meant to assess your ability to figure out percent by mass and also to kind of give you a break from moles and equations. So if you're having a hard time with those 3 questions, go ahead and skip to the back side and come back to it later. Maybe you'll recall what you're supposed to do in the process of working on these. First question, we're looking for the percent by mass of the water in hydrated copper sulfate. So in order to figure this out, we first need to calculate the GFM. I'm going to move this down a little bit. And we have 1 atom of copper. We have 1 atom of sulfur. Now the oxygen, because I know I'm going to look at this separate, I'm going to count these 4 oxygens together, and I'm going to count the water together as one thing. So for the oxygen and the copper sulfate, there are 4. And then the water, I have 5 of. So I'm going to put that there. And if you haven't memorized it yet, which you don't have to, the GFM of water is 18.02. And to figure that out, I just have 2 of the hydrogens at 1.01, so that's 2.02. And then I have 1 oxygen at 16, which is 16, and then when you add that up, you get the 18.02. So that is where that is coming from. Oxygen is 16. Sulfur is 32.07. And then copper is 63.55. There's no need for you to memorize any of these. They're all right here. So you can check me too, make sure I'm doing it right. There's the copper, here's the sulfur, here's oxygen, and hydrogen's kind of hidden right now. Okay, so now we just multiply, which this one is still going to be 63.55 and 32.07. And this works out to be 64. And the 5 waters are 90.1. Now we add them up to get the total GFM. And the mass of the whole is 249.72. So that's grams per mole. Now, in order to figure out the percent by mass, it's mass of the part, this is on the back of your reference tables too, over mass of the whole times 100. In our case, since we're looking for water, we need the mass of all 5 waters. So our part is 90.1 over the whole, which is the GFM, 249.72, and then we multiply by 100. And when all is said and done, you should get 36.08%. So in a sample of hydrated copper sulfate, you should get 36.08% of that as water. Next question, what is the mass? So this time they're not looking for the percentage, they're looking for the actual mass of sodium in a 50-gram sample of sodium chloride. So we need to figure out the formula of sodium chloride first, in case you don't know it already. Here's sodium, it's a +1. Here's chlorine, it's a -1. Their oxidation numbers are going to cancel out. We don't need any subscripts. We do need to figure out the proportion of sodium in the sodium chloride. So the sodium for this question is going to be the part, and the whole will be the GFM of sodium chloride. So we still need to do that, but what I'm going to do is I'm not going to multiply by the 100 in this one because we're actually looking for the mass. So let's go ahead and figure out the GFM. And then we just add those up, and we get 58.44 grams per mole. Now we set up our proportion. The part was the sodium, which is 22.99, divided by the whole, which is 58.44. This fraction, the way you have it set up right now, is the fraction of sodium in sodium chloride. So if I take this fraction, this proportion of sodium in sodium chloride, and multiply it by any mass of sodium chloride, any sample mass I may have, it will give me the mass of sodium. So instead of multiplying by 100, I'm going to multiply by that 50 grams, and that's going to give me my mass of sodium in my 50-gram sample. So that means I have 19.7 grams of sodium in a 50-gram sample of sodium chloride. So the only real difference between the question we did first and this one is that instead of multiplying by 100 to get a percentage, I multiplied by a mass to get the mass. So that's how you should look at it to help you get through those questions. Next one, what's the percentage by mass of iron and iron 3 chloride? Very nicely, they told us the oxidation number of iron. Chlorine's always -1 if it's the last part of the compound. Those don't cancel out, so we must have 3 chlorine atoms in a molecule or in a sample of iron chloride. So to figure this one out, again, I need to figure out my GFM. And I need to look up iron. I think it's 58.85. 55.85. And then we do the math, 55.85 and 106.35, and then just add the two up. And we get for our GFM 162.2 grams per mole. So that's going to be our mass of the whole. Our part, they're asking for the iron and iron 3 chloride, so we put our 55.85, and this time they're looking for a percentage, so we're just going to multiply by 100. And we get 34.43%. And that's the percentage of iron and the iron 3 chloride. We'll do another one, same deal. This time we have copper 1 chloride, so it's a +1, chlorine's a -1, no subscripts. So copper we have 1. Chlorine we also have 1. Those masses are just coming off the periodic table. I just happen to have a few memorized, and we add them up. You get 99. By the way, normal chemists don't have those memorized, but we do this stuff all the time. All right, so now we're looking for copper in the copper 1 chloride. So the copper, it's 63.55 is the part, GFM is the whole, and we're looking for the percentage, so we're going to multiply by 100. And when you do, you get 64.19% copper in copper 1 chloride. We have one more, and not surprisingly, this time we're asking for mass. So this one we're not going to multiply by the 100, we're going to multiply by the mass they gave us. And the sample is water. So water is H2O. We did this at the top, but I'll walk through it here. We have 2 hydrogen atoms for a total of 2.02. For oxygen, we have 1 for a total of 16. When we add that up, we get 18.02 grams per mole. They are looking for the oxygen in the water, so the oxygen is the part that goes on top. Then the GFM goes on the bottom. And since we're looking for the mass, instead of multiplying by 100, we're going to multiply by that mass that they gave us. And you end up with 221.98 grams of oxygen in that sample of water. And that makes sense. The majority of the mass comes from the oxygen. And that's how to do the practice quiz. Hopefully you can try some different examples. Maybe some we've done on practices and some we've done on practice quizzes or homeworks in order to help you prepare. But also it's important to ask questions if you have them. Ask those questions the day before the quiz. That's the best time to get your questions answered.